It's a nice gloomy day here in Augusta, Georgia, so might as well talk about something exciting like momentum. A lot of people have heard of this word before. A big train going down the railroad tracks really fast, we might say has a lot of momentum. It's hard to stop a train because it has so much momentum. A lot of times sports announcers during a football or basketball game will say that a team that scores a bunch of points real quick, they have a lot of momentum behind them, so the other team might call a timeout to stop the momentum, and they use it in that sense. But the question really becomes, what is momentum? Because it's sometimes of a vague idea. Momentum is a property that an object has when it's moving. It's almost that simple, but there's a little bit more to it than that. A moving object has kinetic energy. We know that. And the amount of kinetic energy that an object has is the amount of work that it can do. Now, if we go back to our definition of work, in order for an object to use its kinetic energy to do work, it must apply a force through some displacement. Now, this force that an object has comes from momentum, and it comes in the form of an impulse. Now, we're going to talk about impulse more later on. I just want to focus on momentum right now. Now, I'm not saying momentum is a force. It's not. But it's kind of like a force. I'm not saying momentum is kinetic energy, but it's kind of like kinetic energy. Momentum is another property that an object has when it's moving, just like it has kinetic energy. Momentum can be considered to be part force, part kinetic energy, and really just simply part inertia. Mathematically, momentum is a pretty simple calculation. Momentum, P, is equal to mass times velocity. Mass is in units of kilograms. Velocity is in meters per second. Our unit for momentum is kind of a strange unit. It's kilograms meters per second. It'd be nice if they simplified that down into some singular unit, such as the Epperson, but that's not going to happen unless I do something spectacular in the next couple of years and they name that unit in honor of me, but I'm not expecting that. Remember that velocity is a vector, and so what that means is that momentum is also a vector. And just like velocity can be broken up into the x and y direction like you might have done with projectile motion, momentum can also be broken up into the x and y direction like any other force, like velocity or acceleration or force. That's going to become more important when we talk about the conservation of momentum, not necessarily with momentum per se. But we'll come back to this idea to break it up later on when we talk about conservation of momentum. Now, remember, a moving object has momentum. Momentum, mass times velocity. It's a pretty easy calculation, but it's pretty boring. It just simply says how much momentum a car, an object has when it's moving. It's kind of hard to relate it to something real. Momentum becomes more important not just when an object is moving, but when two or more objects interact. That's when momentum is really cool, and that's why we want to study momentum. Now, when I talk about interactions, we talk about things like collisions and explosions, really cool things. Two cars hitting, a bomb exploding. These are all examples where momentum comes into play and can give us a lot of information about what's going to happen. Now, these interactions and what happens during the collisions and explosions, that's where we got to look at conservation of momentum. But momentum itself is simply a property an object has when it's moving, similar to kinetic energy, similar to force.